Hi everyone, welcome back to my channel Mathematics Appetite. And today, as the board exam, the Karnataka State Pre-University Board exam is nearing, so the timetable it has come. So by May the exam will be conducted. So many students started asking me to solve and to analyze the question paper. As you know, due to this COVID pandemic, so there is certain syllabus reduced for the board examinations. According to the latest, the reduced syllabus, there are model papers released from the State Board of Karnataka Pre-University. So I'll be discussing and analyzing that paper. So what are the questions they have? It may be mathematics, physics, chemistry and biology. So according to the students' need, the students started asking continuously, they started texting me. So I have planned to do this series of videos of question paper, model question paper solving, that is second PUC Karnataka board, the state board examinations will be doing it. And anyway, the people who are new to my channel, hi, this is Chiranjeevi, I am a maths teacher. So I have been doing many various mathematical concepts, like, so I'll be dealing with the 10th standard CBSE chapter by chapter concepts. I'm doing already. There are many chapters completed and few chapters more to complete. And also intensively I'll be doing the engineering mathematics M1, M2, M3 and M4 for VTU University, the syllabus under VTU. And also for BSc I'll be taking mathematics for for all the 6 semesters. I'll be coming up with the interesting and superb videos. And also I'll be doing the coordinate geometry. Soon I'll be coming up with the coordinate geometry and the basics and complete things in the Cartesian coordinates. So we are not going to discuss about the polar coordinates. We'll see later if time permits. So many things I have in my mind to do. Anyway, so I had no idea of doing PUC, but still, due to the student forces me, and many students started texting me that it helps really. So that I planned to do the second PUC question paper. It's from the Karnataka Pre-University Board. They have released 2 model papers. So let us discuss that model paper, what are the types of problems, how to solve that, and later on, if time permits, let me go deeper into many other types of problems also. Okay, so the first thing here in the model question paper 1 of Karnataka board, the first problem 1 mark. So they are given like this. Okay, the first problem in the model question paper 1 in the 1 mark. So today I will be discussing about the calculus, that is differential calculus. That is continuity and differentiability, differentiation and applications of derivatives. So these 3 chapters under the differential calculus, I'll be taking that problems and be solving in this video. The future coming video I'll be taking integration, integral calculus, and also then later on chapter by chapter I'll be going and focusing. Today I'm focusing on the differential calculus. The first problem here is they ask us to differentiate, so tan root x, the function y is equal to tan root x. I hope you know what is the meaning of function. Y is equal to f of x, where x is the independent variable and y is the dependent variable, isn't it? So as the x changes in the graph, if you see, as the x changes, the y changes. So y is dependent on x and x is independent. We can take any values, and in the chapter of function you have been discussed, you have been studied deeply about the domains, ranges, all these things, right? Yes. So this is y of x, a function. Now we are going to differentiation, that is derivative of a function. What is the derivative of a function? Any function, the instantaneous rate of change, what is happening with respect to x and y, and that is the derivative. And also you can call it as tangent to the slope. Any slope you can take. See, if you take, see, this is the curve, change in dx and change in dy, right? We'll be taking dy by dx, and this, if we bring this very closely, we'll be getting a tangent, right? This tangent, and of course the tangent point we can call it as the derivative of a curve. Okay. So anyway, this problem they have given the model paper. Let us see. Y is equal to tan root x. So while differentiating, what we have? We have d of dx of y, derivative of y, that is nothing but d of dx of tan root x, right? Okay. So here we are going to use chain rule. It is just 1 mark. Chain rule. How we use chain rule? First we should know what is the derivative of tan x. What is derivative of tan x? So d by dx of tan x is nothing but secant square x, isn't it? The derivative of tan x is d by dx of tan x is secant square x. Yes, we will be doing it. Say, observe carefully, it is chain rule. You should know chain rule, you should know product rule, you should know quotient rule, what are the derivatives, how it is happening, all these things. So here we have d by dx of tan root x. So I am going to differentiate this. So here it becomes dy by dx, that is nothing but, so d by dx of tan x. For tan x, it is secant square x. So it is secant square root x. In the place of x, we have root x, right? It is secant square root x into d by dx of root x. Why we are doing this? It is chain rule. Whenever, for example, if we had some power here, first you should deal with the power, then the function, inner function, finally it goes and ends with the x. That is the chain rule, right? So here, first I have taken with respect to tan root x, the derivative of tan x is secant square x, and I have taken secant square root x because tan x is secant square x. So in the place of x, we have root x. So secant square root x into derivative of this root x. If at all there is some other function, we have to differentiate that also. So what will be getting? We will be getting secant square root x into what is the derivative of root x? So root x is minus 1 by 2 root x, right? D by dx of root x is nothing but minus 1 by 2 root x. Isn't it? How will you take this? You can see this. Root x, you can solve this. Root x can be written as 1 by 2. Isn't it? That is equal to, if you differentiate this, x to the power of n, the derivative of x to the power of n is nothing but nx to the power of n minus 1. So what happens here? This is going to become 1 by 2 into x 1 by 2 minus 1. Isn't it? That is equal to 1 by 2 x to the power of 1 by 2 minus 1. It is 2. It is minus 1 by 2. Right? So that is equal to 1 by 2 x to the power of 1 by 2, that you can write as 1 by 2 root x. Okay, so this is the derivative. Sorry, I have taken minus here, so there is no minus. So the derivative of root x is 1 by 2 root x. We can do it also. How we are going to get 1 by 2 root x for this derivative? I hope you are understanding. So this step is not needed, just I have explained you. So these are the two derivative formulas we have used. That is d by dx of root x is 1 by 2 root x. So secant square root x into d by dx of root x is nothing but 1 by 2 root x. So the overall answer is secant square root x by 2 root x. This is the answer. So this is the derivative of tan root x. Likewise, you can take any cos root x, sin root x. So with respect to sin and cos, you differentiate. Again, you differentiate with respect to root x. That is x. We will be getting the answer. I hope you are understanding. So this is one more problem which we saw it in the model paper. Okay. So next problem, 2 marks problem. I'll go to a problem that is, we have to find dy by dx. So we have to find that dy by dx. So if y is equal to, we have y is equal to cos of log x plus e to the power of x. This is the function they have given, x is greater than 0. So this is the function they have given, a 2 mark problem in the model paper. Y is equal to cos of log x plus e to the power of x. So we need to find dy by dx. It's just simple. Just find dy by dx. So dy by dx is nothing but d by dx of cos of log x plus e to the power of x. That is nothing but, so what is the differentiation derivative of cos x? If we take d by dx of cos x, what we have? It is minus sin x, isn't it? The derivative of cos x is minus sin x. So we will be taking that. So here we will be getting minus sin. In the place of x, we have log x plus e to the power of x. So log x plus e to the power of x into differentiation or the derivative of this function. This is called as chain rule, right? So we will be having log x plus e to the power of x. Okay, understand carefully. For cos, it is minus sin x. Okay, so in the place of x, we have the complete log x plus e to the power of x. So for cos, if I differentiate, I'll be getting minus sin log x plus e to the power of x. Again, I'm going to differentiate this until I get the single letter, until x. So first, if there was some power here, I need to handle the power first, then the function, then the inner function, and goes on up to it ends with x. Understanding? This is called as chain rule, right? Again, I'm differentiating this. What I'll be getting? That is minus sin of log x plus e to the power of x into. So how will you differentiate this? So d by dx of log x is 1 by x, right? For log x, it is 1 by x plus e to the power of x, the same e to the power of, the derivative of e to the power of x, e to the power of x. Before solving these problems, first to go through the derivative formulas, integral formulas, become thorough with that, and then you start solving. It is very, very easy. Okay, so now let me arrange it in a proper order. Minus 1 by x plus e to the power of x into sine of log x plus e to the power of x. Okay, this is the derivative of this function dy by dx. So this is dy by dx, okay, of the function y is equal to cos of log x plus e to the power of x. I hope you are enjoying, and it's very interesting. This is one of the 2 marks. So the next problem is again finding dy by dx. I hope you are understanding. If anything is there, you can just comment in the comment section. I'll be very happy to clear the doubts. Okay, so next we have to find dy by dx if sine square y, this is also 2 marks problem, plus cos square y is equal to 1. Okay, so it is sine square x. Sine square x plus cos square y is equal to 1. We need to find dy by dx. Okay, yes, it's very simple. Just you differentiate this. What's going to happen? We have d by dx of sine square x plus again differentiating this d by dx of cos square y, that is equal to d by dx of 1. Just LHS and RHS, every term I am going to differentiating with respect to x. Be careful, we are differentiating with respect to x. So what's going to happen here? For sine square it is 2 sine x. Why? Because the derivative of x to the power of n is nothing but nx to the power of n minus 1. Isn't it? This formula we are using. The derivative, the first derivative which we study by using the first principles, right? X to the power of n is nothing but nx to the power of n minus 1. Same thing I have applied. Sine is taking the form of x. So sine square x is nothing but 2 sine x. Again chain rule. For sine x, we need to differentiate. It will be getting minus cos x. So better write like this: d by dx of this sine x plus d by dx of cos square y is 2 cos y. Okay, so because we are differentiating with respect to x, here we have the complete term as y. Whenever we differentiate with respect to x and where there is some y term, so then obviously when you differentiate it, you should put dy by dx. So whenever you are differentiating with respect to x, and if you are differentiating y, the overall differentiation with respect to x and some y term, then you differentiate it as usual, whatever the derivative you have, but put dy by dx. So 2 cos y dy by dx. For cos y we need to do it right. d by dx of cos y into dy by dx, that is equal to 0. You know, for constant term it is 0, right? For constant term it is 0. Yes, now we are going to differentiate. See how it's going to happen. 2 sin x into derivative of sin x is cos x plus 2 cos y, derivative of cos y is minus sin y into dy by dx, that is equal to 0. Isn't it? So how can you write this? That implies, so 2 sin x cos x, let me write this, 2 sin x cos x minus, here we have minus, right, minus 2 sin y cos y dy by dx is equal to 0. Okay, so this one I am just rearranging, this minus I am multiplying, will be getting this. Okay, now we are going to find dy by dx, right? So what I am going to do, since this has minus, I am going to change that side. Anything is fine. Okay, let me keep this side only. So that implies what is going to happen, minus 2 sin y cos y dy by dx, that is equal to, if this I can send that side, what is going to happen, it's going to become minus 2 sin x cos x. Isn't it? This one I am going to send that side. I am going to keep this in the LHS only. This one I am going to send that side, RHS. So plus 2 sin x cos x. If it goes that side, it becomes minus 2 sin x cos x. Understanding? Yes. Now what I am going to do, I hope you have studied trigonometry. So what is sin 2 theta? What is sin 2 theta formula? It is 2 sin theta cos theta. Isn't it? Sin 2 theta is nothing but 2 sin theta cos theta, or sin 2x is nothing but 2 sin x cos x. So here we can find, okay, if you use this formula, so here you can find in the form of 2 sin y cos y and sin x 2x. So what I am going to do, just I am writing in this form 2 sin y cos y. So sin 2y, you will be getting minus sin 2y. I hope you are getting, I am using the trigonometric relation, the multiple angles and submultiple angles formula, not submultiple, multiple. So you will be having sin 2 theta is nothing but 2 sin theta cos theta. So instead of 2 sin y cos y, I will be writing sin 2y dy by dx, that is equal to minus 2 sin 2x. Okay, so here also sin 2 theta is nothing but 2 sin theta cos theta. So 2 sin x cos x is nothing but sin 2x, will be having minus. So minus minus gets cancelled. So what is dy by dx? Dy by dx is nothing but, we have sin 2x by sin 2y. So this is the required dy by dx of this function if sin square x plus cos square y is equal to 1. So just differentiate LHS just with respect to x, and see whenever you differentiate with respect to x and there is some y term, be careful, you should write dy by dx. Otherwise we will not get dy by dx only, and that becomes wrong. I hope you are understanding and enjoying. Yes. So next we'll go to the next problem. Okay. Next problem we have, if y is equal to, we have x cube plus tan x. We need to find the question is d square y by dx square. What is the meaning of this? It is the second derivative. If at all you differentiate a function, you will be getting some answer. Again that function, if it is differentiable, if we differentiate that, then we will be getting second derivative. You can go on like d cube y by dx cube also, third cube. In higher studies, in your degree, you will be studying the nth derivative also. Okay, so this is the second derivative we have. Okay, so if y is equal to x cube plus tan x, they have given the function, and we need to find the second derivative, that is d square y by dx square. Yes, let's find out. See what's going to happen. Y, so that is dy by dx is nothing but, if you differentiate y, you'll be getting dy by dx because with respect to x we are doing it, right? So dy by dx, and for this is d by dx of x cube plus d by dx of tan x. That is nothing but, so in the previous problem I wrote what is the derivative of x to the power of n? It is nx to the power of n. So here we will be getting nx to the power of n minus 1, 3 minus 1 plus, so here it is tan x. What is the derivative of tan x? It is secant square x, isn't it? So that is equal to, what we will be getting? We will be getting 3x square plus secant square x. Okay, so this is dy by dx. dy by dx, we got it as 3x square plus secant square x. Now what they asked d square y by dx square, which means again we are going to differentiate this with respect to x. So we have dy by dx as, let me write down here, we have dy by dx as 3x square plus secant square x. Okay, yes. So now what I am going to do, I am going to again differentiate this. So what happens here, it becomes d by dx of dy by dx, that is nothing but, so you can differentiate this side, d by dx of 3x square plus d by dx of secant square x. That implies, what's going to happen here, we have d by dx of dy by dx, so this is going to become d square y by dx, and dx will be getting dx square. This is the second derivative, that is equal to, what is the differentiation of derivative of 3x square? X to the power of n, so you will be getting nx to the power of n minus 1. So this 2 will be getting here, so 2 3s are 6, x to the power of 2 minus 1 will be getting 1. So this is 6x. I hope you are understanding the previous problem. I wrote the derivative and showed you how the x to the power of n is happening. Okay, so this is 6x plus, for secant square x. So whenever we use chain rule, I am telling you, so I am repeatedly telling that whenever we use chain rule, first target the power, then the function, then the inner function. So here we have secant square x, so first 2 into secant x, because x to the power of n is nx to the power of n minus 1. So 2 into 2 minus 1 will become 1. No need of writing that. So 2 secant x into, now we are going to see the derivative of secant x, because this is a chain rule. First I have operated the power, then the function, now I am differentiating this function. So what will be getting? I will be getting 6x plus 2 secant x. What is the derivative of secant x? Derivative of secant x, it is secant x into tan x, isn't it? This is the formula. So you will be getting secant x into tan x. So that is nothing but 6x plus 2 secant x into secant x, we can write it as secant square x into tan x. You can take 2 common or just leave this as it is. So this is d square y by dx square, the second derivative of the function given x cubed plus tan x. I hope you are understanding. Yes. Okay. So these are all 2 marks questions I am solving. We'll go for the next question. We'll see. Okay. So the next question is, we have if y is equal to x cube plus tan x. So we have if y is equal to x cube. Okay, this is the one we solved, right? Sorry. Okay, so next we'll go to find the slope of the tangent to the curve. They're asking slope of the tangent to the curve y is equal to x cube minus x at x is equal to 2. Yes, this is the question. We need to find the slope of the tangent to the curve. So this comes in the applications of derivatives chapter, right? Okay, we are going to see how to find the slope of a tangent. First of all, before going to the slope of a tangent, let me explain what happens with respect to d by dx. Whenever we have a function like this, so the run and the race, right? This becomes dx and this becomes dy, right? So this dy, this point, let me take this point and this point as a and b. So if this point comes near, whenever the derivative we calculate, it should be infinitely very small, right? When we apply the first principles, applying the limit as x tends to 0, as x tends to infinity, so it is very closer. As these points come closer to very small point, we'll be getting a tangent at this point, right? This tangent, as this point comes to close, we'll be getting a tangent. So that for calculating, just we can take dy by dx and solve. That is nothing but that slope of the tangent. So this is the slope of a tangent, this is the positive slope and this is the negative slope, right? So slope of the tangent we can calculate. So in general, if you want to calculate the slope of the tangent, just solve for dy by dx. It's as that. So they're asking, we have the function y is equal to x cube minus x. Okay? Yes. So now I'm going to differentiate. Dy by dx is nothing but d by dx of x cube minus d by dx of x. So that is nothing but, what is the derivative of x cube? I said that x to the power of n is nx to the power of n minus 1. So it is going to become 3x to the power of 3 minus 1, which is nothing but 2. 3x square minus, what is the derivative of x? It is 1, right? Yes, 1. So this is dy by dx. What we got dy by dx? We got 3x square minus 1. Now they are asking find the slope of the tangent to the curve y is equal to x cube minus x at x is equal to 2. They are mentioning the x value, that is x is equal to 2. So just substitute x value. It's done. Dy by dx at x is equal to 2 is nothing but 3 into, so what is 3x square, right? X is nothing but 2. So 2 square minus 1, that is nothing but 3 into 2 square is nothing but 4 minus 1, that is 3 4s are 12 minus 1, that is equal to 11. So 11 is the slope of the tangent of the curve y is equal to x cube minus x at x is equal to 2. So this way you will be finding the slope of the tangent. I hope you are enjoying and understanding. Yes. Next we'll go to the next problem, that is 3 marks problem, a very important problem. Okay, so far we were discussing just with respect to x, somewhere we'll get y, then we are going to put dy by dx. Now let us see some different problem with respect to 3 marks problem. In your model paper 1 they have given this problem. Let us see that how to solve it. Yes. So they have given that if x is equal to 2a t square, and they were given y is equal to 80 to the power of 4. Okay, so we need to find dy by dx. So we need to find dy by dx. They are given x is equal to 280 square, y is equal to 80 to the power of 4, dy by dx we need to find. Okay, so here there is some strange alphabet t we can find here, right? This variable t. So they are asking us to differentiate the function with respect to x. As x varies, y also varies. But here some strange variable t has arrived. How to do it? So here we need to do two parts differentiation, which means, so in two stages you need to differentiate to get dy by dx. The first thing, take this and differentiate with respect to t. So here it is t, right? So we are going to differentiate this with respect to t. How? First, differentiate with respect to t. So x is nothing but dx by dt. We'll be getting dt because we are differentiating with respect to t. So dx by dt, that is equal to d by dt of 280 square. I hope you are understanding. So dx by dt is nothing but d by dt with respect to dt we are doing, with respect to t we are doing. So 280 square. So that is nothing but, so you know the constant a and the x to the power of n. What is the derivative of x to the power of n? It is nothing but nx to the power of n minus 1. Here n takes the value 2. Already we have 2 here, so it is going to become 4at. 2 minus 1, it is going to become 1. I hope you are understanding. Yes. So if separately x and y is given and t is there, or any other alphabet for such matter, if there is no t, if you take z square, for example, if you have z square here, z to the power of 4, then differentiate with respect to z. That's it. Any m you can take with respect to m. Okay, so you can take any variable as it is given. With respect to that, we are going to differentiate. So first we took this x is equal to 280 square and we differentiated with respect to t. We got this 480. Okay, next we are going to take y is equal to 80 square, 80 to the power of 4. Again also this y function we are going to differentiate with respect to t, that is dt. So dy by dt is nothing but d by dt of at to the power of 4. I am going to differentiate with respect to t. So that is nothing but what it will happen, a is constant and we will be getting 4t to the power of 4 minus 1. That is nothing but 3. It's very simple, don't get confused. Very simple, very basic derivatives I am using to differentiate this. So 480 cube, right? So dy by dt we have 480 cube and dx by dt we have 480. Now to find dy by dx, we need to find dy by dx. So dy by dx is nothing but, since we have differentiated with respect to t, the y and x, just what you do in the place of dy, you can put dy by dt by dx by dt. You can just divide this. Okay, dy by dt by dx by dt. It's as simple. So dy by dt is nothing but 480 cube by, you can get cancelled, dt you can get cancelled. That is why I have taken this. It is very simple form, don't get confused. So dy by dt, in the place of dy I have just divided dt in the numerator and the denominator. So dy by dt is nothing but 480 cube and dx by dt, that is nothing but 4at. So that is nothing but 4 gets cancelled, a gets cancelled, 1t gets cancelled, here 2 is remaining. So t square is dy by dx. Therefore if x is equal to 280 square, y is equal to 80 to the power of 4, then dy by dx is nothing but t square. This is 3 marks problem. Carefully deal with that. Step by step you need to write it. Okay, and you need to show that dy by dt is t square. Is it interesting? Yes. Okay, another interesting problem we have for 3 marks. Let us solve that. Okay, now we need to find dy by dx if whatever the function they have given, yes, x to the power of y is equal to y to the power of x. Yes, so this is the function they have given, x to the power of y is equal to y to the power of x. We need to differentiate this and we need to get dy by dx. Always be careful, students. Whenever we get the exponent power like this, whenever it is very tough to solve, how to solve this? There is some power y and there is some power x. It becomes difficult to solve. If it was xy, we can use the product rule, first into differentiation of second plus second into differentiation of first. We can solve that. Whenever we get like this, always use the help of a special mathematical relation, a mathematical concept called logarithms. It plays a vital and very major role in all domains of mathematics. Taking log and putting it and making it simple and solving it. Isn't it? Such type of problems will be using logarithms. Just take a log. What's going to happen? So take log on both sides. Okay, take log on both sides. What's going to happen? This is log of x to the power of y, that is nothing but log of y to the power of x. Okay, so I am taking log on both sides. So you should know the rule of a logarithm, log of a to the power of x. Okay, log of a to the power of x can be written as x log a. Okay, so log of a to the power of x can be written as this x, the power comes in front of the log, and x log a. Anything for such matter you can take. For example, log of m to the power of n is nothing but n log m. You can take like this. Okay, so the power is going to come this side. So now we have simplified, right? We can use it, right? I hope you are understanding. So just I am applying this rule here. So log of x to the power of y, where does the y come? Y comes in front of log. So it becomes y log x, that is equal to, here x is in the power. So that is going to become x log y. Okay. So now differentiating this. See, we have two things multiplied here, y into log x and x into log y. So whenever we have like this, what we are going to use? We are going to use the product rule or the UV rule. Okay, so d by dx of u into v is nothing but u into derivative of v plus v into derivative of u. This is the product rule. Okay, so this is the product rule we have, that is first into derivative of second plus second into derivative of first, or you can take u into derivative of v plus v into derivative of u. This is the product rule. Whenever you get two products, you are going to use this rule. Yes, so we will be using it. See how we will be using it? First into first uv. So here this is going to be u and this is going to be v. So this is going to be u and this is going to be v, right? Yes. So what's going to happen here? First into u into derivative of v. So here v is log x plus log x v into derivative of u, that is y. That is nothing but same thing here also. We'll be taking this as u and this as v. Right? So what's going to happen? First into, that is u into derivative of the second, that is log v log y plus log y v into derivative of first, that is x. Okay, so by using log it became very simple, right? Yes, let us solve this. So what's going to happen here? See, first into y into, what is the derivative of log x? D by dx of log x is 1 by x, right? Plus log x into, what is the derivative of y? Be careful, I am repeating again the previous problem we have solved. When we are differentiating with respect to x, right? Whenever we arise the term y, we need to write dy by dx. So log x into the differentiation of y is dy by v. That is 1 dy by dx. Directly we will be writing dy by dx. That is equal to x into the derivative of log y. Again we are dealing with y when we are differentiating with respect to x. So x into log y is 1 by y into dy by dx. Again I am writing that dy by dx plus log y into the derivative of x is 1. So obviously I will be writing log y. Okay. So what we have here, we have that implies y by x plus log x into dy by dx, or in a single step let me write this. Okay, let me bring the dy by dx one side and send this that side. So log x dy by dx, keeping this, I am going to bring this dy by dx, so it is x by y, right? So minus x by y into dy by dx. I hope you are understanding. I am keeping this in the LHS only. I am bringing this dy by dx for simplification this side, and already we have log y here, that is equal to log y. If this y by x goes that side, becomes minus y by x. I hope you are understanding. So what I am going to do, I am going to take dy by dx as common. So we will be having dy by dx of, what is the remaining here? We have log x minus x by y. Okay, log x minus x by y, that is equal to, let me take LCM here, it is going to become x log y minus y by x. Understanding? I am taking LCM here. So x log y minus y by whole divided by x. I hope you are understanding. So that is nothing but that implies, here also I am going to take LCM. What happens if I take LCM here? It is going to become y log x whole divided by y. Y log x minus x whole divided by y. Now what I am doing, I am going to take this side. So when the product crosses the equal sign, it is going to become divided by. So what will be happening? Dy by dx is equal to, already we have x log y minus y divided by x whole divided by, this is going to come here. So that is nothing but y log x minus y whole divided by y. I hope you are understanding. Just I am bringing this side, it is going to be divided by. So what's happening here? Okay, so if you take this, see whenever we have like this, this is going to become d by dx. So this is going to be reciprocal, right? So this is going to become y by, so the overall answer is y by x into x log y minus y by y log x minus y. This is the overall derivative. It is 3-mark problem. It is very simple. Observe carefully. Once again I will revise this. So we have x to the power of y is equal to y to the power of x. Such type of equations, if we use log, it is going to be very easy. We need to use log, so taking log on both sides. So the logarithm property I discussed, whenever there is power like this, that comes in front of log. So y log x is equal to x log y. In order to make this only, we used log. Again the product rule we used. So u into v is u into derivative of v plus v into derivative of u. We are going to substitute there and start differentiating and equating it, simplifying. We'll be getting this. So y by x into x log y minus y by y log x minus y is the dy by dx of this function, that is x to the power of y is equal to y to the power of x. I hope you are enjoying. It's as much easy. Just observe carefully, understand the basics and how the derivatives comes. Okay. Next problem we have is we need to find the intervals. This applications of derivatives. Okay. Find the intervals in which the function f is given. F of x is given as we have x squared minus 4x plus 6. So first one we should see strictly increasing. And the second one strictly decreasing. Okay, it is strictly increasing and it is strictly decreasing. Before going to see the intervals where it is strictly increasing and strictly decreasing, first let us differentiate this. So we'll be getting f dash of x is nothing but, so directly if I'm going to do, just look here, x square is nothing but, let me write this, d by dx of x square minus d by dx of 4x plus d by dx of 6. What's going to happen? This is going to become 2x to the power of 2 minus 1, 2x minus 4. Product rule applying, 4 into x is 1, derivative of 1. So a constant will become 0, so minus 4 plus 0, the constant term. So overall we will be getting it as 2x minus 4. Okay, this is the derivative. Okay, so for find the internals, the differentiative, that is the derivative of f dash of x should be equal to 0. We will be equating that to 0. So what happens? We have 2x minus 4, that is equal to 0. So 2x is equal to 4. So x is equal to 4 by 2. So x is equal to 2. We have a single variable, x is equal to 2. In order to find the intervals, so if you take the inequality sign, you can solve it by that also. It becomes a little bit hectic if the function is complex. So you just take a number line or some real line. Take 2. So the left it is minus infinity, for right it is plus infinity. Right. So first one we will be discussing what's happening with respect to x. Okay. So here x is 2 and we have just taken 2 and we have represented the real line or the number line. So here it is minus infinity and here it is plus infinity. Now what is going to happen? The first condition, let me take. What is the first condition? If x is equal to, if x is less than 2. So this x, if I take any x here, x is less than 2, right? From minus infinity to any x value if I take, then that is x is less than 2. What happens if x is less than 2? Then 2x minus 4, whatever the derivative we have, that will be less than 0, right? So 2x minus 4 will be less than 0. So that, so the strictly decreasing, okay, strictly decreasing, this becomes strictly decreasing interval can be taken as minus infinity to 2. Okay, so this is the interval for minus infinity to of strictly decreasing, because x is less than 2, 2x minus 4 is also less than 0, isn't it? Yes. So if we take the second condition, that is if x is greater than 2, if you consider any x value crossing to this side, okay, that is 2 to plus infinity, what's going to happen? We'll be having 2x minus 4 greater than 0, therefore the strictly increasing is 2 to plus infinity. So therefore for strictly increasing it is 2 to plus infinity, okay, in the open interval, and also strict decreasing minus infinity to 2. So this how we'll be finding the intervals of f of x is x square minus 4x plus 6. I hope you have understood. So in the model paper 1 we have another 4 marks problem. Let us see that. Okay, let us see the form of problem. Find the value of k. They are asking us to find the value of k. Find the value of k if they have given the function f of x is equal to kx plus 1 if x is lesser than or equal to pi, and cos pi if x is greater than pi. Okay, if it is given is continuous at x is equal to pi. Okay, so this is the question. We need to find the value. It's a 4 marks question given in the model paper. Find the value of k if f of x is nothing but kx plus 1 if x is lesser than or equal to pi, cos pi is if x is greater than pi, is continuous at x is equal to pi. They are telling it's a continuous function. Whenever we have continuity, then we can take the limits. Already you people have studied the left hand limit, right hand limit, the laws, rules related to limits, undetermined forms, all these things, right? Yes. So here applying the limits, whenever the f of x is continuous at x is equal to pi, so we can take like this, that is LHL left hand limit is equal to RHL right hand limit, that is equal to f of pi in this case, or f of a in general case. So whenever they tell the function is continuous, then LHL will be equal to RHL, that will be equal to f of a or f of pi. Okay, so this condition we got it. First let us find LHL. So for LHL, see, limit as x tends to pi minus. From left we are going to limit. So limit as x tends to pi minus. So less than or equal to 0 will be getting kx plus 1. So this is f of x. Let me take first f of x. That is equal to limit x tends to pi plus means, or a plus means we are coming from the right, RHL right hand limit, f of x, that is equal to f of pi. As of now this is not needed. Okay, so now first let us find first limit x tends to pi minus f of x. So for left hand limit, if you take pi minus, from this side we are coming, okay, left hand limit f of x is nothing but kx plus 1, because x is less than or equal to pi, so it is the left, so we will be getting this kx plus 1. So I am going to take this as kx plus 1. Okay, so that is nothing but limit h tends to 0. So let me write that, and afterwards let me substitute here. So here we have limit, okay, f of x, that can be written as limit as h tends to 0. We are taking an interval h here, h tends to 0, f of x minus h, because here it is from left hand limit. So what happens if you take this? That implies limit x tends to pi minus kx plus 1 is nothing but limit h tends to 0. Okay, in the place of x we are going to put x minus h. Here h is nothing but pi, right? Okay, so here, so we'll be taking here as h tends to 0, k into x is nothing but we'll be putting x minus h. okay, plus 1. So now I'm going to substitute this 0 here. What is going to happen? And x we are going to have pi, right? So here k into x minus 0 plus 1. Okay, so that is nothing but we have kx plus 1. Let us have this kx plus 1 as it is. Now we are going for a right hand limit. So limit as x tends to pi plus f of x is nothing but limit as h tends to 0 f of x plus h, because here we are having the right hand limit, so we'll be getting x plus h. For left hand limit it is x minus h. Careful, listen carefully. So limit x tends to pi plus, yes, x is greater than pi, so we'll be taking this cos pi, right? So cos pi is nothing but limit h tends to 0, okay, cos of, okay, so what is there here? Cos of, in the place of pi we are going to put x plus h, right? Yes. So that is nothing but, I'm going to put 0 here. It is going to become cos 0, applying the limit. So that is nothing but cos 0. That is nothing but cos of pi, that is nothing but minus 1. Right? So cos 0 is nothing but cos pi, and that is nothing but minus 1. Okay. So here, sorry, I have written it wrongly. Sorry. See here, this is going to become pi. So cos of pi plus h is 0. That is going to become cos pi, that is equal to minus 1. Okay. So here also we can write this k pi plus 1. In the place of x, x is tending to pi, right? So we can write k pi plus 1. Now we got LHL. This is LHL, right? Okay. This is left hand limit, and this is right hand limit. But according to the question we have, it is continuous at x is equal to pi, so we can equate these two. Let us equate what is LHL. We have k pi plus 1. So k pi plus 1, that is equal to minus 1 RHL. So k pi is equal to minus 1 minus 1. That implies k pi is nothing but minus 2. So therefore k is nothing but minus 2 by pi. This is the value of k. So if you are very familiar about how a function is continuous or it's not continuous, what is happening with respect to the limit, in that concept, if you are thorough, then you can understand this. It's very easy. And whenever the function is divided like this in intervals, be careful in taking it. Okay, I hope you understood this. Yes. So I have completed model paper number 1, which is released by the Karnataka state government. Okay, the same calculus part, just differential calculus I have discussed. Same thing, I'll be coming up with the model number 2 in the next video. Then we later on go to the integral calculus, etc. And further, if time exists, I'll be doing physics, chemistry and biology also. Thank you. Have a great day. Start preparing. Don't waste your time. Greatly achieve great in your life. Thank you. Bye. Take care.